Here is our next problem. 3 over x plus 7 plus 4 over x minus 8. And right off the bat you can see that these denominators are different, and that's going to cause a problem. We have to get them the same. Now, a lot of students get confused here on how you actually do that. Some people might say, well, we can subtract to make this 7 negative 8. Well, no, you can't do anything like that because this is a quantity. So you cannot add to or subtract from a quantity. It's just not something that we can do mathematically. You can't just add and subtract to the top and bottom of fractions. The only thing you can do is reduce, divide the top and bottom, or multiply the top and bottom. So with that being said, let's look back at our number problem we did here. We said, oh, 1/2 and 2/3, let's just multiply by the other denominator. So we multiply by 3 here and 2 here. We're going to do the same idea with quantities. So this denominator is going to be multiplied by this denominator, and vice versa. So here's how it will look. This fraction on bottom is going to get multiplied by x minus 8. So that means on top we have to do the same. You can't just do it to one side of the fraction. We're multiplying by x minus 8 on bottom and on top. And then the second fraction, we're actually multiplying by x plus 7 on top and bottom. So what you do to the bottom, you do to the top. And this is what it will look like. Now to help you a little bit, we can do some highlighting. You can see originally we had x plus 7 in only this denominator. But we multiplied by x plus 7 on top and bottom over here. Different color highlighter, we can look at the exact same idea with x minus 8. X minus 8 was only on the right side, so we decided to multiply by that quantity on top and bottom on the left. At this point, our denominators are exactly the same. Both have x plus 7 times x minus 8. So at this point, we can now combine the two fractions. Now over here, we need to keep track of some of our steps. Our first step here normally is to factor the denominator if possible. Now here we didn't need to factor the denominator. I started off with an easier problem. So what we first did was we multiplied, so write multiply to get common denominators. And by the way, resist the urge to cancel. Don't cancel. Don't undo what you just did. A lot of students are tempted to do this. But right here, this x minus 8 over x minus 8, we don't want to cancel it because then our denominators aren't the same. We just multiplied by that on purpose. So resist the urge, don't cancel. We just multiplied to get common denominators. At this point, we're going to add the numerators. We're actually going to do the steps from above. Now that we have common denominators, we're going to do all the steps that you do when you have common denominators, which is first add the numerators. So we'll end up with 3 times x minus 8 plus 4 times x plus 7 all over our one denominator, x plus 7 times x minus 8. Again, resist the urge to cancel. You cannot cancel x minus 8 here and here. You know why? There's an addition sign right here. That makes this like a mega huge quantity. This term plus this term. So we cannot just cancel off a piece of a term. Can't do that. So instead, we're going to distribute these constants out front, and then we're going to combine like terms. So first distribute, and we end up with 3x minus 24 plus 4x plus 28 all over our denominator. And now that numerator is still a huge quantity, we need to combine like terms. So the 3x and the 4x becomes 7x, and negative 24 and 28 becomes just positive 4. And it's all over that denominator. Now, we're still doing these steps from up here. It says factor if possible. Well, this is already factored, and the 7x plus 4 can't be factored anymore. Now it says cancel any common factors. I don't see anything in common. And then it says state any excluded values. So now we look at our original factored denominator. We didn't cancel anything, so it's still this right here. And then we just say x cannot equal negative 7 or positive 8. Both of those would make the denominator 0. And we're done. So that's how it's done. This is a simpler problem. It might not be simple to you guys, but this is actually a simpler problem of combining fractions that have different denominators. And our last problem we're going to do is just a little bit more complex than this. I'll save the really hard ones for whenever I get back. So, last example we're going to do in our foldable is 2 over 3x squared plus 12x plus the fraction 8 over 3x. So, let's go through our steps. The first step says factor the denominator, or I should put denominators, if possible. So if we look at these, this second one's a monomial, can't be factored. But this first denominator has two terms, and it looks like they have some things in common. So I'm going to factor out a GCF of 3x, and x plus 4 is left behind. And the second fraction just stays the same. Alright, now step 2 says multiply to get common denominators. So as you can see, these two denominators already have something in common. They both have 3x. So I don't need to multiply either denominator by 3x. They already have that. But this denominator is missing the quantity x plus 4. So we're going to multiply just this fraction by x plus 4 on top and bottom. The first fraction is just going to stay the same. So we have 8 times x plus 4 over 3x times x plus 4. So all I added here, or all I changed in the problem from this step to this step, is I multiplied to get my common denominator. At this point, the denominator is now the same. So we can do the steps from above. Now remember, don't be tempted to cancel. You just multiplied by this, so you don't want to cancel. Alright, so steps from above say add the numerators. So I'm going to go ahead and actually from this step to this step, I'm going to not only add the numerators, but I'm going to distribute my 8. So I'll end up with 2 plus 8x plus 32. That just saves me a step of writing it out all over again, just to distribute. So I've added my numerators, and it's all going to be over the one common denominator. I have one more step, and that is to combine like terms. So I have 8x plus 34 all over 3x times x plus 4. Now at this point we're on step 3, where we're going to look to see if we can cancel any common factors. So it looks to me like there's no common factors at all. And so then the very last thing I need to do is state my excluded values. which are going to be 0 and -4. So as you can see, if you follow the steps, then it's very systematic. It's tedious, but it's very systematic. Now, you may be thinking, well, I'm not going to have these steps on my test. This is true. That's why you need to practice, practice, practice with the steps so that it becomes second nature. And always remember, this is mimicked by numbers. The way you add fractions without variables is the same as the way that you add fractions with variables. We just have to do a couple more steps, like factoring and finding excluded values. But the main idea is the same. Multiply to get common denominators, then add across the top and keep the bottom the same. So now go ahead and glue this in. I believe we're gluing on page 77. And then the sub, you should pause and let them glue that in. And there's 2 practice problems that I want you to tackle on page 78. And these are the 2 problems. And do these as a team. I understand that you might struggle a little bit, and that's okay. But when I come back on Wednesday, I want to be able to see what you could do. Sean's there. He can kind of walk around and help you guys. My 6th hour, he's not there. So just do the best you can with each one, and then we'll talk about where you got hung up whenever I get back on Wednesday. Good luck.